Hello students, welcome to the e-learning platform of BSIT's Mechanical Engineering Department. I am Viren Birdi and we are studying manufacturing processes. This is unit number 3, casting processes and plastic molding. In the previous video we have seen the different defects that can be seen in a casting. At the end of this video, you will be able to select relevant plastic molding processes for the given job with justification. So we are going to study plastic molding in this particular video. So let's get started. Before starting with the plastics, let us understand the term polymer. Now the term polymer is derived from the Greek word mero, means unit. So polymer means many units, isn't it? Mero is unit and poly means many, so it is many units. Polymers consists of chains of molecules. Monomer stands for one single unit and polymer means many units which are joined together by a chemical reaction. Homopolymers are made up of same type of monomers and copolymers are made up of two or more type of chemically distinct monomers. Okay. Natural polymers are those which are derived from plants and derived from animals also. Like examples are wood, rubber, cotton, silk and wool. The polymerization is a term which is a process of forming the polymer. Isomers, it is the phenomenon where different atomic configuration are responsible for the formation of same configuration. Now, what are the different characteristics of these polymers? Number one, they are light in weight. Then they have high corrosion resistance. They have low density. The thermal and chemical properties are low in case of polymers. Then they are also having low mechanical properties, and to improve these mechanical properties, sometimes they are reinforced by fibers. Fiber reinforcement करून त्याची आपण ताकद वाढवू शकतो, strength वाढवू शकतो. Because actually the polymers are low in mechanical properties. They are having low coefficient of friction. The cost is less and they are easy to fabricate. And lastly, it can be produced in various colors. So these are the different characteristics of a polymer. Now, what are the different processes through which we can form a polymer? The first process is addition polymer. Addition polymers are produced by process of addition polymerization. Now, addition polymerization is a process in which single repeat monomer units are attached one at a time in chain-like manner to form a linear macromolecular. Okay. So it is going to be addition of many monomers, and these many monomers come together to form a polymer, and that is the reason it is known as additional polymerization. The second is copolymerization. Now copolymerization occurs when many monomers do not polymerize with themselves but copolymerizes with other compounds. आपण मागच्या स्लाइडमध्ये बघितलं होतं की कोपॉलिमर म्हणजे काय, की इट इज अ कॉम्बिनेशन ऑफ मेनी डिफरंट केमिकली डिस्टिंक्ट मोनोमर्स. तर या केसमध्ये तेच होतं की ॲडिशन पॉलिमरायझेशनमध्ये सिमिलर जे मोनोमर्स आहेत ते एकमेकांना अटॅच होत जातात, पण कोपॉलिमरायझेशनमध्ये मात्र वेगवेगळे मोनोमर्स हे एकमेकांना अटॅच होत जातात. इट इज द ॲडिशन पॉलिमरायझेशन ऑफ two or more different monomers forming copolymers. The examples are styrene and butadiene combined to give a copolymer of butadiene styrene, rubber used in tires. So these are the examples of copolymerization. Then we have condensation polymers. Condensation polymers are produced by the process of condensation polymerization. Condensation polymerization is also known as step growth polymerization. So that is not in our syllabus, so we will not go much deep into that. It is the formation of polymers in stepwise intermolecular chemical reactions that normally involve more than one species of monomers. Now let us see the classification of plastics. Basically, the first type of plastic is thermoplastic polymer. Okay, now what are the characteristics of these? They are formed by addition polymerization. Addition polymerization जी प्रोसेस आहे त्यांनी हे थर्मोप्लास्टिक पॉलिमर्स तयार केले जातात. They are linear polymers composed of chain molecules. They are soft, weak and less brittle. Softening is possible on reheating due to weak secondary forces. थर्मोप्लास्टिक पॉलिमर्स आपण बऱ्याचदा रिहीट करू शकतो आणि सॉफ्ट करून त्याचे शेप्स चेंज करू शकतो. दे कॅन इझिली मोल्डेड अँड रिमोल्डेड. एक शेप तयार केला, तो शेप जर नको असेल तर आपण परत किंवा यूज झाल्यानंतर आपण तो परत मेल्ट करू शकतो आणि मेल्ट करून त्याला आपण रिमोल्ड करू शकतो. दॅट इज इन केस ऑफ थर्मोप्लास्टिक पॉलिमर्स. दे कॅन ऑल्सो बी रिसायकल्ड. बऱ्याचशा आपल्या ज्या पाणी पिण्याच्या बॉटल्स आपण बघतो त्या रिसायकल होतात कारण त्या थर्मोप्लास्टिक पॉलिमरच्या बनलेल्या असतात. दे आर सोल्युबल इन ऑर्गॅनिक सॉल्वंट अँड टॉईज, फोटोग्राफिक फिल्म्स, इलेक्ट्रिक इन्सुलेशन्स आर द एक्झाम्पल्स ऑफ thermoplastic polymers. The second type is thermosetting polymer. Now they are formed by condensation polymerization. The process is different. थर्मोप्लास्टिक कशाने तयार करतो आपण तर ॲडिशन पॉलिमरायझेशननी आणि थर्मोसेटिंग आपण तयार करतो कंडेन्सेशन पॉलिमरायझेशननी. दे आर कंपोज्ड ऑफ 3-dimensional networks of cross-linked molecules. They are hard, strong and more brittle. Softening is not possible on reheating due to strong covalent bonds. थर्मोप्लास्टिक पॉलिमर्स आपण कित्येकदा रिहीट करू शकतो, त्याचे शेप चेंज करू शकतो, पण थर्मोसेटिंग पॉलिमर्स मात्र आपण रिहीट करू शकत नाही. एकदा का त्याला शेप दिला की त्याचा शेप आपण परत चेंज करू शकत नाही कारण they are having strong covalent bonds. They cannot be remolded in any desired shape. एकदा शेप दिला की झालं, त्याच्यानंतर आपल्याला ते परत रिहीट करता येत नाहीत आणि रिहीट करता येत नसल्यामुळं मेल्ट होत नाहीत आणि मेल्ट न झाल्यामुळं आपण त्याला रिमोल्ड करू शकत नाही. They cannot be recycled also. They are insoluble in any organic solvent. Telephone receivers, electric plugs, switch panels are the examples of thermosetting polymers. Now let us discuss the two plastic forming processes. The first is calendering. Rubber or some other thermoplastic sheets are formed by calendering process. Thermoplastic मटेरियल्सच्या काही शीट्स आणि रबर हे आपण कॅलेंडरिंग प्रोसेसने तयार करतो. इन दिस प्रोसेस द प्लास्टिक कंपाऊंड इज हीटेड अँड पास्ड थ्रू द रोलर्स. जे मटेरियल आपल्याला फॉर्म करायचं आहे ते आपण गरम करतो आणि ते वेगवेगळ्या रोलर्समधनं पास करतो. द प्रिन्सिपल इज सेम ॲज रोलिंग प्रोसेस. दॅट इज material is compressed between rolls and immersed as a sheet. जे मटेरियल आपल्याला थिन शीट्समध्ये फॉर्म करायचं आहे त्या मटेरियलला आपण 2 रोलर्समधनं कॉम्प्रेस्ड करून पाठवणार, पास करणार आणि पास केलं की त्याच्या दुसऱ्या बाजूला आपल्याला त्याच्या शीट्स मिळू शकतील. The thickness of the produced sheet is dependent on the gap between rollers. किती थिकनेसची शीट पाहिजे ही आपण त्या रोलर्समधल्या गॅप मेंटेन करून ठरवू शकतो. Here we can see the process of calendering. इकडनं आपण ती शीट पाठवा लागलेलो आहे. हे फीड रोलर्स आहेत. या फीड रोलर्समधनं ही शीट पुढे जाणार आणि आपल्याला दिसेल की इथं पहिल्यांदा जाड शीट आहे आणि ती जशी जशी पुढे चाललेली आहे तसं तसं 2 रोलर्समधलं गॅप आपण कमी करत नेत चाललेलो आहोत आणि अल्टिमेटली या ठिकाणी आपल्याला फायनल पासमधनं ती आपल्याला जास्ती चांगली जी ॲक्च्युअल थिकनेस पाहिजे आपल्याला तो इथनं आपल्याला झालेला दिसतो आणि मग इकडे ती आपण पुढं गुंडाळतो. ओके, सो दॅट इज हाऊ कॅलेंडरिंग इज डन विथ द हेल्प ऑफ रोलर्स. During the process, the first roll gap serves as feeder. पहिले जे रोलर्स आहेत ते फीडर म्हणून काम करतात. The second as metering device and the third one sets the gauge of the gradually cooling plastic which is then wound. The application of this particular process is producing vinyl, polyethylene, cellulose acetate, etc. Now let us see a small video of this calendering process.
Once again, the very beginning of mixing and turning and milling the PVC. They keep on milling it until it gets to the right gauge and the right temperature. All the air becomes out of it. Here's another close-up of the calendar. That's the thin ribbon of PVC that's fed through. It gets completely smashed through these heavy duty pressurized rollers into that film, comes back down here into the width that's been desired. This is all trim right here, and then gets spun back through the machine where it's going to meet the backing. Now this is the back side of the calendar, so you can see at the top the ribbon comes down, it gets spread into a film which is right there, and then it gets fused right back onto the backing, which is this white thing coming through. The backing and the PVC get fused together through the calendering process. So the third stage is then basically, as it got fused over there together, those were the two parts where they met. Here comes the clean sheet of PVC vinyl, and it gets cooled down through these cooling rollers. It gets wound up through the back side here, and then after this it'll go to this next station, which is the embossing station.
Another process is thermoforming. Now it is a series of processes for forming thermoplastic sheet over a mold with heat and pressure. नावातच आहे थर्मो, म्हणजे आपण ते गरम करणार आहे. ओके, सो गरम करायचं आणि प्रेशराइज त्याच्यावरती प्रेशर द्यायचं आणि अशा पद्धतीने आपण त्याला आपल्याला ज्या फॉर्ममध्ये ते प्लास्टिक पाहिजे आहे, जो शेप आणि साईज पाहिजे त्याच्यामध्ये त्याला कन्वर्ट करायचं. Heating is carried out by radiant electric heaters located on one or both sides of the starting plastic sheet. There are two methods for this. The first is vacuum forming and the second is pressure forming. Let us see. We'll discuss vacuum forming. So it employs a clamp to grip the plastic sheet having thickness of about 0.126 to 3.2 mm. एक प्लास्टिक शीट जी साधारण 0.126 टू 3.2 mm आहे ती आपण क्लॅम्पच्या सहाय्याने पहिल्यांदा ग्रिप करतो किंवा पकडतो. A heater is used to bring the polymer to a temperature of about 66 to 90 degree Celsius. ती जी शीट आहे त्याला आपण हीटरनी साधारण 66 ते 90 डिग्री सेल्सिअस पर्यंत गरम करतो. Though the small holes in the die through the small holes in the die, vacuum is applied and the snagging plastic sheet is thus pulled tightly against the mold shape. जे त्या डायमध्ये स्मॉल होल्स आहेत त्याच्यातनं व्हॅक्यूम किंवा सक्शन अप्लाय करून ती जी प्लास्टिक शीट आहे ती त्या मोल्ड शेपवरती टाईटली पुल केली जाते. As the mold is cooler, the polymer is chilled and stiffened by die contact. तो मोल्ड गार असतो आणि त्याच्यामुळं हे गरम झालेलं जे पॉलिमर जेव्हा त्याच्यावरती चिकटतं तेव्हा ते गार होतं आणि स्टिफ होऊन जातं. Let us see the
All
video.
thermoforming methods have 6 processing steps. They are load, heat, form, cool, part removal, and trim. Load. The sheet is placed in a clamp frame and held down on all 4 sides. Heating. After loading, the sheet is ready to be indexed to the heating station. Depending on the machine design, the sheet will be indexed to the heaters or the heaters move to the sheet. In either case, heaters above and below the sheet heat the plastic to its forming temperature, typically from 285 degrees to 375 degrees Fahrenheit, depending on the type of plastic. As the sheet is heated, it loses strength and begins to sag. To experienced thermoforming personnel, the amount of sag and the shape of the sag is a useful indicator of how evenly the sheet has been heated and how well the plastic can be formed. For some part designs, the sheet is intentionally heated unevenly to improve the plastic distribution in the formed part. Molds for production are usually made of aluminum. Aluminum is easy to machine from a solid block or be cast from a pattern. Aluminum is an excellent conductor of heat, so it cools the plastic parts efficiently. Prototype molds and molds for low production quantities might be made out of wood, fiberglass, and even plaster. When the sheet is sealed against a mold surface, air under the sheet is trapped. Using a vacuum to remove the air forces the sheet against the mold surface. The air under the sheet leaves the mold through vents. To remove large amounts of air, the mold has gaps in the assembly. Drilled vent holes are used in locations where small volumes of air are likely to be trapped. Here is the simplest of the thermoforming methods. The plastic sheet is heated in a clamp frame until it's rubbery. A vacuum removes the air from under the sheet, and atmospheric air pressure stretches the sheet into the mold. Some regions stretch more than others, and this causes uneven sheet thickness. In this part, made in a female mold, the thickest plastic is at the top flange, where the sheet first touches the mold surface and begins cooling. The sheet becomes thinner as it was stretched to the bottom of the cavity. The distribution of the sheet in this female mold is thickest at the top flange, thinning down along the walls, and the thinnest at the base of the molded part. If we form the part on a male mold, the mold moves up to the heated sheet. The plastic first touches the metal at the projection, and this plastic is held there and begins cooling. The rest of the sheet thins as it is stretched to the flanged region. The sheet is sealed around the mold and vacuum is applied. Atmospheric pressure presses the sheet onto the mold. The sheet distribution is the opposite of the previous mold, thick at the base of the formed part and a decreasing sidewall thickness towards the flange. The flange itself will have varying thickness, thin at the corners, thicker towards the clamp frame. Drape thermoforming is where plastic sheet is draped over a male mold. The sheet stretches as it is pulled. Another way to stretch the sheet into a deep section is called plug assist. In fixed plug assist, a plug is attached to the upper half of the mold. The mold closes and the plug stretches the sheet. A vacuum then pulls the sheet onto the surface of the mold. The plug has pre-stretched additional plastic where it is needed. The shape of the plug affects the sheet distribution to improve the part thickness along the bottom and in the corners. A variation of plug assist is third motion plug assist, where the plug moves into the sheet after the mold is closed. Basic thermoforming causes the sheet to be thinnest where the plastic sheet is stretched the most. There is very little control over part thickness. Plug assist and drape assist are methods to improve the sheet thickness distribution in thermoformed parts. In this example of plug assist, a plug moves into the sheet. Until the vacuum is started, air trapped under the sheet causes the plastic to billow and begin to climb up the sides of the plug. The plug should not cool the plastic and may even be temperature controlled. The plastic next to the plug keeps its thickness, but the plastic not in contact with the plug continues to stretch and thin. When the vacuum is applied by either a timer or a position sensor, the sheet is pulled away from the plug and onto the cavity walls, where it cools quickly. It's apparent that sheet distribution is affected by how far the plastic climbs the plug before the vacuum pulls it away.
So that is about the plastic molding processes. With this we are completing unit number 3. In the next video we are going to start unit number 4, forming processes. Till then, thank you for watching and take care.